Hello, my name is Carlos Cortés. I'm a PhD student from the Technical University of Madrid, and I'm here to present the paper Qualitative Experience Study of Natural Interaction in Extended Reality Environment for Immersive Training. First of all, I will start with an introduction about immersive learning in XR environments. After that, I will explain the XR natural interaction setup with the description of the use case task and how we build the construction use case. Finally, I will present the quality of experience that we addressed and its conclusion and future work. Now I will disappear so you can focus on the presentation. Virtual reality and immersive equipment have gained popularity for industrial training environments. This is because they allow us to reproduce situations saving cost and danger. Moreover, extended reality enables interaction with the local reality by mixing the real and the virtual world. This opens opportunities for immersive learning as the users can interact with elements of their local reality like their hands, tools, and augmented objects. While devices exist to integrate hands in extended reality, most of them rely on invasive devices as haptic globes or controllers, and this can lead to a disruption of the immersion. To overcome this issue, we propose a natural interface method. In this paper, we present an industrial learning environment with natural interaction and realistic avatar representation. In addition, a qualitative experience experiment has been carried out by expert people to validate the use case in terms of immersion, cybersickness, and interactivity. The script of the construction use case consists of a step-by-step tutorial in which the user must review visually and through metric measurements a construction reproduced in virtual reality. Extended reality requires the creation and coordination of local and virtual realities, as well as real-time integration of user and interactive objects. So our natural interaction XR setups contains the creation of a virtual world, the creation of a local reality setup, and also how we embed the user and interactive objects through color segmentation. For building the virtual world, we used a real 360 picture rendered on a virtual sphere. The feel of the environment also uses realistic texture to keep the realism. On the other hand, the local reality has been built by coordinating 3D model objects with the real ones. But to coordinate the local and the virtual reality, we need to place those 3D models in the same place as the real ones. For this purpose, we developed a wall calibration scene. These calibration scenes allow us to place virtual objects in real space. In order to correctly position virtual objects, the calibration scenes allow us switching between extended and augmented reality. Here is a video, an example video. And in order to be able to interact in a real time and in a natural way, it is necessary to introduce the local reality into the extended one. In our case, we use the front-facing cameras of the HMD, that these cameras capture the local reality and bring it into the virtual reality. Afterwards, color-based processing is performed, this chroma key, to segment the hands and interactive objects. Finally, here is an example of the entire task. The user starts in the virtual wall. I see the floating text explaining the situation. Then the user enters into a special area for changing the floating text. Then the user goes to the coordinated 3D model of the table and read the design document. Then the user verify that the material for reconstruct the handhold is the correct according to the design document. And then, using this measuring tape, he verifies the width of the handhold too. Measuring immersion is key to assessing how natural interfaces affect the quality of experience. Consequently, we decide to assess the user's immersion for validating the learning environment. During the experiment, 14 expert subjects performed the experience. After that, they had to perform a subjective questionnaire evaluating quality of experience factors. These quality of experience factors were the sense of presence, the visual quality, the simulator sickness, the global quality of experience, and the usefulness for training purposes. Here we can observe the results of the questionnaires with 95% confidence intervals. On the left, the 3 presence factors covered in the studio show similar high scores. These values are similar also to previous studies for the same measurements. For the visual quality on the right, we can see that most of them report as good quality. There is only an exception, which is the measuring tape that score worse than the others. Here are the results for the global quality of experience and the usefulness for training purposes of this tool. Here we can observe that the most users report that the quality of experience was good or better, and none of them rated as poor or worse. Also, most users also found the method to be useful as a training method. The result shows that the measurement of the presence and overall quality were reported as good and had a good acceptance. Although the visual quality of most of the objects scored well, the measuring tape, which was integrated by segmentation, scored worse than the rest. This was caused because of the camera resolution that wasn't good enough for representing the numbers of the measuring tape. As a conclusion and future work, our results suggest that the system can be used for training of workers, particularly supervisors, in the context of construction. Also, that the system need for some improvement in the visual quality of complex segmented objects like the measuring tape, and also that further research is needed to validate this technology with more users and more scenarios. So thank you for the attention, and now you can ask me whatever you want about the paper. Thank you very much.